Hello friends, from today's question. In the situation shown in the figure, there is no friction between 2 kg and ground. So we have three parts. For what maximum value of R value of force F can all three blocks move together? B. Find out the value of force F at which sliding starts at other rough surfaces. C. Find the acceleration of all blocks, nature and value of the frictional force for the following value of force: 10, 18 Newton, 25 Newton. This is the figure. We have three blocks A, B and C, and force F is being applied on the 2 kg block, which is the middle one. The frictional coefficient between the A and B is given as 0.5, and between 2 and 3 is given as 0.2. Okay, so let us call this as mu1 and this as mu2. So this is our mu1 and this is our mu2. So first of all, let's find out the two values of the friction. Okay, let's draw so this is our A block, this is B, and this is our C block. Force is being applied on block B. So this block B will try to move block A along itself. So let us, with the help of the frictional force, let us call it Fr1, and equal and opposite will be acting on block B also. This is Fr1, and similarly we are going to have B will try to force C with help of frictional force. Let us call this Fr2, and equal and opposite will be acting here, that is Fr2. Let us find out what will be the maximum value of Fr1 as well as Fr2. So we can say that our Fr1 max, which in cases is also called as a limiting. So we have given this as mu1 mass of A into G. Mu1 is 0.5, mass of A is 1 kg and G is 10. So this value will be coming equal to as 5 Newton. And similarly, you can find out Fr2 max, which is mu2, and here it will be mass of A plus mass of B, the mass of A plus mass of B into G, and mu2 is given as 0.2. This is 1 plus 2, that is 3 into 10. So we get this as will be equal to 6 newtons. So these are the limiting value of the friction Fr1 as well as Fr2. And from here we can see that block A is being moved or driven with the help of friction force Fr1. So driving force of block A is Fr1. So we can say the maximum acceleration of block A will be for Fr1 is equal to Fr1 max, and which is equal to 5 newtons. So now we can find out the maximum acceleration of block A. You can say therefore the maximum acceleration of block A, which can be write as A max for A will be equal to FR1 max divided by its mass, that is MA, and FR1 max is 5 Newton, MA is 1, so we get maximum acceleration of A is 5 meter per second square. Similarly, we can find out for block C also. We can say the driving force for block C is FR2. So it means maximum acceleration of block C will be for FR2 is equal to FR2 max. So we have maximum acceleration of block C of block C, this will be equal to A max of block C FR2 max. FR2 max is our 6 Newton, so FR2 max divided by mass of C, it is 6 divided by 3, so this will be coming as, sorry, it is 2, this will be coming as 3 meter per second square. Now we know that the maximum acceleration of A is 5 and maximum acceleration of C is 3. So if they have to move together, so you can say for blocks A, P and C to move together, the acceleration should be either of A or of C. Okay, so if they have to move together, the acceleration of A plus P plus C will be 3 meter per second square. Okay, because the C can only go up to the maximum value of 3, where this 3 comes within the range of acceleration of A. Okay, so A can at least travel with C, but with 3 meter, but C can only travel with maximum of 3 meters. Okay. So we can say as block C can maximum move with 3 meter per second square, whereas block A can at least move with, at least also move with 3 meter per second square. So we found out, okay, that means this is the maximum acceleration with which all 3 blocks will move. You see, therefore maximum acceleration of A plus B plus C is equal to, let us call this capital Mx. This will equal to 3 meter per second square. Now based on it, we can find out that the maximum force which can be applied, so we can say the maximum force that can be applied so that A plus B plus C move together will be equal to F max, and this is equal to the acceleration A max, and we have there mass of A plus mass of B plus mass of C. Okay. A max is 3 and this is 1 plus 2 plus 2. So we get F max as, this will be coming as 15 Newton. So this completes our first part. Now for the second part, we are going to find out the value of force F at which sliding occurs at other surfaces. Okay. So we have two surfaces. So this is B. Okay. So let us check first sliding between B and C. Sliding between B and C. So we already know that the maximum force that can be applied on B is 15 Newton, so that all three move together. So if applied force is greater than 15 Newton, then at least B and C will be moving with the different acceleration, or they are going to be sliding. So this means if F is greater than 15 Newton, sliding between B and C starts. Okay. So this is the value of the force for which the sliding between B and C is going to start. In the second part, we are going to find out the sliding between B and C. Sorry, not B and C, but A and B. Okay. Second part, sliding between A and B. So we already know that we have this over A, this is over B, and this is over C. And we know that the maximum acceleration of A, we already found out, is 5. So you can say maximum acceleration of block A is 5 meter per second square. So it means of block A, missed A. So it means if the acceleration increases beyond 5 meter per second square, the sliding between A and B is going to start. So you can say from here that if acceleration of A plus B is greater than 5, then sliding between A and B starts. So from here we can say this is the acceleration of 5 meter per second square, and we have here Fr2, and this is applied force F, and this is Fr2. So the acceleration of combined A plus B should be greater than 5 meter per second square. Okay. So based on this, we can write the equation that F minus Fr2 will be equal to 1 plus 2 multiplied by 5. This comes equal to 15 Newton. And from here we can say F is equal to Fr2 is equal to Fr2 max, and its value is 6 Newton. So it means F will be equal to 15 plus 6. So from here we can say the value of applied force is 21 Newton. So this value of force sliding starts between A and B. Basically it means for this value of force the acceleration becomes of A and B, A plus B rather, becomes greater than 5. So as soon as it becomes greater than 5, the slipping is going to, or sliding going to start from between A and B. Okay. And next we are going to find out the now we come to the C part. C states that find the acceleration of all the blocks, nature and value of frictional force. Okay. So we come to C part, and C part, first one, the value of applied force is 10 Newton. Now this value of applied force 10 Newton is less than the maximum force, and the value of maximum force is 15 Newton. So under this condition, all the blocks will be moving with same acceleration. You can say all blocks move together with same acceleration. Okay. And suppose that value of acceleration is A, given for A plus B plus C, and applied force is 10, and total weight is 1 plus 2 plus 2. So this will be coming equal to as 2 meter per second square. Now let us find out the value of the friction. Okay. Both the friction between is A and B and B and C. So we can say our Fr1 will be equal to mass of A into A plus B plus C. Mass of A is given as 1 and this is 2, so we get this as 2 Newton. And similarly we can find out Fr2, which will be equal to mass of B, A plus B plus C. Mass of B, so this is coming as 2A, 2 into 2, and this will be coming equal to as 4 Newton. this is the value of acceleration and respective value of their friction Fr1 as well as Fr2. Now let us consider case 2. Case 2 is giving us applied force is 18 Newton. Okay. So we have F equal to 18 Newton. Now this value of force is obviously greater than the 15 Newton, that is maximum value. You can say applied force F 18 is greater than F max, whose value is 15 Newton, but applied force F, which is 18, is less than 21 Newton. So in the shorter form we can write that 18 is greater than 15 but less than 21. So under this condition, when force is, then the slipping is going to start with B and C but not between A and B. You can say from here sliding starts between B and C but not between A and B. So we can further solve it and find out the, you can say, values. So we have our A and this is our B and we have this our C. Now applied force is of 18 Newton. This will be our Fr2 and as there is sliding, this will be 6 Newton. We already found this, and here will be also Fr2, and we say the acceleration of C is AC in this direction. And A and B will be moving together, so we can say their acceleration is A plus B in this direction. Excuse me. So block A and B move together with acceleration A plus B, which is equal to, we have 18 minus 6 and divided by 1 plus 2, and this will be coming as, this will be 12 and 3, this will be coming as 4 meter per second square, and we can find out the acceleration of C. Okay, block C move with acceleration AC, which is equal to Fr2 divided by its mass is given 2, so Fr2 is 6 divided by 2, so which we get as 3 meter per second square. And yeah, we are also supposed to find out the force of friction. Okay, so A and B are moving together, so we can say Fr1 will be equal to Fr1 is 1 into force acceleration is 4, so this is 4 Newton, and Fr2 will be equal to Fr2 max, which we already calculated as the sliding between B and C. This is becoming a 6 Newton. Now we come to the third part. Applied force F is now 25 Newton. Now this 25 Newton is greater than our 18 Newton, and 25 Newton is also greater than 21 Newton. So it means now the sliding is going to start between all the 3 blocks, which basically means sliding takes place between A and B, as well between B and C. So all 3 will be now moving with different acceleration. It means all 3 blocks will move with different accelerations. So let us draw this is block A. Let us suppose it moves with acceleration A in this direction, and we have a frictional force rather, Fr1, which will equal to Fr1 max. We have block B. We have applied force F, which is 25. Here we are going to get Fr1 max, and here we have C block, which will be Fr2, which will equal Fr2 max, and here we are going to get Fr2 max. Okay, let us suppose this acceleration is C and this acceleration is AB. So we can say acceleration of A will be equal to Fr1 max upon 1. So Fr1 max is 5. So we get 5 meter per second square, and acceleration of B is equal to 25 minus this value is 5 and one value is 6, minus 5 minus 6. Mass is given as 2, sorry, this is MA, and we get this as 7 meter per second square. And finally we get acceleration of C, which is Fr2 max 2, and Fr2 max is 6 divided by 2, which will be getting as 3 meter per second square. And value of friction, as there is sliding, you already, so value of the friction Fr1 will be equal to Fr1 max, and Fr1 max is 5, and Fr2 will be equal to Fr2 max, which is equal to 6 Newton. this completes the question. Thank you.